Hello everyone, welcome back to our channel Becoming a ROS Developer. I'm Desire, and today we've got Sharmila, who has just completed the course Linux Basics for Robotics, and she'll be giving us a presentation on that. So what I'm going to do is I'm going to hand over the platform to her so she can begin her presentation. Alright Sharmila, whenever you're ready.
Okay, yeah. Now I'm going to run my robot. Just let me show my. Okay.
Alright, can you be explaining to us what you're trying to do as you go?
Okay, I'm trying to check whether my robot is. I'm trying to connect with my robot. Now it is initializing the robot interface, and now it is ready. Now I'm going to run the obstacle avoidance. Now it is running obstacle avoidance.
Mm-hmm.
And it is set the parameters, and now it is turning left. It just saw
What's going on there?
I don't know.
Alright, let's wait for it.
It
Maybe
works,
it will
but
be able to avoid the other obstacles.
okay. Okay, it starts again. Okay. Yeah, now it works. It is just checking whether the obstacle is near, and now it is turning right. After it saw the obstacle, it is turning right, turning left, and now there is an obstacle ahead, so it is after seeing the obstacle, it just moves. And let me show my parameters, odometric parameters. If the obstacle is ahead, it's just turning whether to move right or left.
Mm-hmm. Did you make any adjustments of how far it is to turn, or the amount of angular distance it covers? Or
First, okay, let me show my code.
no, it's fine. You can continue doing what you're doing right now. I've just observed that it's turning too much in some cases, and in
Yeah.
others.
Actually, I make my angular velocity to rotate if there obstacle obstacle is ahead, I just make my robot to rotate. Then it will steady. After finding a normal straightforward position, it will stop. I set my angular velocity to that. So that's why it is rotating. After seeing the obstacle, after seeing the correct position, it will stop. It will stop rotating. That's what I changed.
Can you explain to me how you control how much it rotates? Just off the top of your head, right? How do you control?
Okay. Yeah, I'm using what can I this is the statistics of it will check the position of x and y, and it will the linear velocity and angular velocity. In my code, I set my angular as -1 for turn. What?
All right. Did you hear my first question, Sharmila?
I can't hear you. Can you repeat me?
My first question. Did you hear my first question? I said, if you were going to explain how you regulate the amount of turning it does, how would you do it, or how did you do it?
To regulate
the amount of turning that your robot does, right? So can you take me through that process? How did you manage to control that?
Yeah. I control the turning using the angular velocity and time. The angular velocity, which defines the rotation, and sleep duration, and tells how it rotates. By adjusting two parameters, I can regulate the amount of turning. I set my angular velocity is -1.0 and sleep is 1.5. This helps to control the speed of the rotation, angular velocity speed of the rotation. The higher value results in faster turning, and the sleep duration controls the robot to how much it keeps waiting for turning, and which directly affects the angle of rotation. Okay. So the angle, okay. If I increase my angular velocity, then my robots turn faster. So I set my angular velocity is -1.0 and my sleep is 1.5. Did I catch your question correctly?
Yes, you answered it correctly. Okay, let's go on.
Okay. Okay.
All right. So let's see the statistics script running. I think that's the one you're trying to execute, right?
Yeah.
Oh, okay.
Okay. Okay, now it shows the position, odometric position of x and y and linear velocity of the robot. And now it is showing the statistics, how it changes. Like it is rotating, so angular velocity becomes -1.0. And it moves linear velocity, and so it shows 0.08.
Nice, very well done. Okay, all right. So take us through your obstacle avoidance script, so you can maybe stop execution and then you open your IDE.
Okay. Can I stop the execution of the robot?
Yes, please.
Okay.
Well, you didn't have to disconnect, but no worries.
Okay. Okay, first, I set my, okay, the source, this the source.robot functions bash helps to connect with the helper functions like reading sensor data and movement commands, and this will display my message. And next, I define the parameters like threshold, forward speed, and turn speed. My threshold represents the minimum safe distance from an obstacle. If the robot has to check the obstacle safe distance, so I mentioned the threshold. And the forward speed, and it I the forward speed I set is 0.08 to control the speed of the robot, and turn speed is 1.0, and it will check how fast the robot rotates. Then before starting, I ensure my angular velocity and linear velocity as 0 and sleep as 1. Then my loop starts, like it will check the front. These values will check the obstacle in different directions, like how much distances in front, left, and right. It will check the distances. Then it will print the sensor. Already you saw my obstacle avoider program, like it will show front, left, and right values. So then this line will check whether my if there is an obstacle in front, and it will use this bz minus l to perform the comparison. And then if there is an then it will detect the obstacle. If there is an obstacle ahead, it will stop and check whether turning left is as a more space, or turning right as more space. For turning left, I said 1 plus positive 1.0, and for turning right, I apply minus 1.0. Then for perform tuning, like I set my for stop turning. Before I said for turning turning, I set as my angular as minus 1.0. To stop turning, I just keep it as 0. Then to move forward, to escaping obstacle, I just after it finds the direction to move forward, it will go linear 0.08, and sleep 1.0. Then my velocity linear will be 0. Then if there is an obstacle is greater than my threshold, then it is a clear path, and it will move forward. This is what my obstacle avoider dash.
Okay, so take me through. So how many cases are you looking at every time you do your index comparisons, right? How many cases are you using?
Yeah, I'm using three cases actually.
3 cases. Okay. So
First, yeah,
sure. Can you explain how you split them?
yeah. First, case 1 is front is greater than. Now this case for turn, I use left is front is. Okay, wait. Okay. For clear path, for no obstacle, I choose greater than or equal to threshold. If there is a no obstacle, the robot continues moving forward. If there is an obstacle, I chose front is less than threshold. And if an obstacle is detected, it will compare which has more distance, like right or left, which has more distance, it will compare and move forward. Then my case 3 is just I told you, like for turn, it has checked whether left is greater than right, or which one is greater than right, and it will move according to you.
Okay, so can you tell me how you can improve this option for your robot, right? How can you fine tune the amount of turning it does? Can you elaborate onto that?
Okay. For turning, I need to increase the resolution for the turning right. Am I correct?
Yes. So remember when I was asking you that what we have got at the moment is that our robot is turning more than required, right, to avoid an obstacle that's in front of it or that's on the side, right?
Okay.
So
yeah,
how can you improve that behavior using the available indexes that you're given?
maybe instead of left and right, maybe I can improve front left and front right.
Can you explain what you mean
For
by
more,
front left and front right?
for more precise tuning decision, I will like it. If the robot is here, then it will check in front whether in front it will check whether the right and front left as more as more distance.
Okay.
I will set my velocity angular as 1 since it is not okay. Since my robot has a fixed angular velocity and fixed time, improved. This can be improved by using a front right and front left. And
Yeah, you have. Okay, so I think you're on the right track, right? You're on the right track. However, you maybe need to look at a little bit of adjusting your angular velocity, right? Because even if you're going to take in
yes,
consideration front left and front right as additional cases to consider, for as long as your robot is turning the same amount, right, you're not really making use of that data. You're not leveraging it correctly. So, uh, given this guide, can you try and re-explain a little bit better how you would do it?
by changing angular velocity.
Not only that, right? That puts the case
Okay.
right in front of you. But there is a little bit more that I want you to look at, right? So, with regards to logic, you don't just change it, but there is more that you can consider. This is what I want you to think about.
Mm, okay. By not only checking the forward, left, and right, maybe front blocked, left free, right free, like the case will work, right?
Yeah. Okay.
Front, if the front is
All right. I
if
think
the front is blocked, okay.
you wanted to say something. If the front is blocked.
Yeah, I'm priority based decision making. Like we can use priority based decision making to avoid the collision.
Yeah. So it's something like that. I wanted you to have some logic that tells your robot how much to turn. Right. That's the whole point. Because if you have a camera that gives you a little bit more than a standard, or if your processing algorithm has got more resolution, that means more cases, right? Instead of 3 cases, maybe you have 5 or 8 cases, for
Yes.
example, right? That means you also have to
Mm,
adjust the logic that is setting your angular and linear velocities accordingly so that it uses that resolution correctly, right? It turns just enough, but not too much, right? Um, so
okay.
you were on the right path, and I would say it's good. You show that you understand what is going on. Maybe you could have explained it a little bit more, a little bit better, but for now it's all right. Okay. So, all right. When you tested in simulation, I'm quite sure you did, right? What variations did you notice, or if any?
First, actually, I tried many by changing linear and angular velocity, and after this one, after changing this evaluation, this one works.
Nice, Shamila.
Choose this one.
Can you repeat what you said?
I chose the I reduced the linear velocity to make the robot slower, and which increase the reaction timing. And at the same time, I also increase my angular velocity so that the robot could move when an obstacle is detected. Then this helped my robot to avoid the obstacle more effectively, and it reduces my forward momentum while improving the turning responsiveness.
Mm-hmm. Mm-hmm. Okay.
Now, and I also noticed in my previous evaluation, the linear velocity is too high and the robot cannot handle, and it may collide, and it always collide with with the obstacle. Then similarly, the angular velocity is also too low. When I first tried, the angular velocity is also low. Then my robot fails to avoid and hit the obstacles. Then I tuned the parameters experimentally, and I until I found a balance and where my robot moves smoothly and avoid the obstacles without collisions.
Thank you. Very, very well done. All right, Sharmila, thank you so much for your wonderful presentation and for explaining to us exactly the stuff that you did and how you did it, right? That's the most important bit. That's the stuff that shows that you understood what you're doing. All right, everyone, this was Shamila's presentation and a warm congratulations to her. Would like to encourage all those of you who would want to try this course or any other one that we offer certification on to do so, and then you can also come and showcase your work here, and then hopefully you acquire the certificate. All right, until next time, keep pushing your ROS learning. Bye bye.